So, what's up guys? This is again your resident round bottom flask and welcome to the part 2 of our video lecture series for the basic concepts of structure and bonding in the context of organic chemistry. So for this video, we will be discussing an essential concept for drawing Lewis structures, which is formal charge. So formal charge, by definition, is a comparison of the number of electrons around a neutral atom or an atom in its ground state versus its number of valence electrons when it is bonded in a molecule. We have to take note that this is not an actual charge of the atom in the molecule, so that means it only exists on paper, but we still do this because this is essential to keep track on how many electrons we have used in drawing our Lewis structure, and also to check whether the Lewis structure is valid or not. So the formula for the formal charge is pretty simple. It's equal to the valence electrons minus the number of bonding electrons, and you divide that number of bonding electrons by 2 minus the number of non-bonding electrons. So before you calculate the formal charge of an atom in a molecule, that means you need to draw first the Lewis structure of that molecule in order to determine the formal charges of all of the atoms in that molecule. Now, the formal charge also, one of the main useful purposes of the formal charge is that it helps us identify which of the following structure is dominant. So how do we know which of the following structure is dominant? So first, it has an overall charge which is closest to 0, and it also has a Lewis structure in which any of the negative charges reside on the more electronegative atoms. And the positive charges reside on the less electronegative atoms. So sorry, nabablanko ako. So let's have, for the second example, let's have an example in comparison for that. So let's have carbon dioxide. Now, I have shown you in your previous video, if you've seen my channel, in the part 1 of this video, I'll show the link is shown somewhere up there. You will see that carbon dioxide can actually have two possible Lewis structures, this one and this one. I will only show you this one, right? Now, if you notice, if we tally all the valence electrons of the atom, on each of the atoms in these Lewis structures, it will show you this one. So this is the valence electrons for carbon and oxygen, and we also show you the electrons assigned to the atom. So that means that will include the number of bonding electrons divided by 2 plus the number of non-bonding electrons. So for oxygen, we have 6 here in this Lewis structure, and one of the oxygen atoms here has 7 valence electrons here because we have 6 non-bonding electrons, and the other one will be from the CO bond because one of them is around the oxygen atom, so that will be equal to 7. For carbon, since it has 4 bonds, so it has 8 valence electrons surrounding it. You divide it by 4, so that means it has 4 electrons assigned to it. Same goes with this oxygen here. Since it has 2, 3, 4, 5 valence electrons assigned to it, it will have 5. So the difference will be the formal charge will be valence electrons minus the electrons assigned to the atom. This is how they do it sa illustration na pinakita ko. And if you notice, on this Lewis structure, the formal charge of all of the atoms is 0, And in this atom here, the formal and in this Lewis structure here, the formal charge of the two oxygen atoms is -1 and +1 respectively. Now, sino yung mas valid? So obviously, this one, dahil lahat ng formal charges ng lahat ng atoms mo is equal to 0. So that will be the dominant Lewis structure. And this is the what we call as the more correct Lewis structure. Lastly, it further validates whether the Lewis structure is correct or not. So how do we validate? So sorry, meron pala akong typo. Wait. So the correct answer for that is the overall charge of the molecule. Ayan, the overall charge of the molecule is the net sum of the formal charges of all the atoms. So balikan natin to ha. Now, how can I say na parehas silang what do you call this? Correct Lewis structure ng carbon dioxide. It's because syempre, all of the formal charges here is 0. So alam na natin na ang carbon dioxide, ang overall charge niya is 0. Now, for this Lewis structure, on the other hand, this oxygen atom rather, has a formal charge of -1, and this oxygen atom has a formal charge of +1, while the carbon atom has no formal charge, or 0 value for its formal charge. So the overall charge of carbon dioxide is the sum of these formal charges. So -1 plus +1, they will cancel each other out. Therefore, the overall charge of carbon dioxide will still be 0. So parehas silang valid na Lewis structure. However, the most dominant will be this one dahil lahat ng atoms niya has 0 formal charges. So let's have this one here. So let's draw the dominant Lewis structure for the following molecules. So let's go back to the steps on how we draw the Lewis structure. So first, we count the number of valence electrons. So we have sulfur and oxygen as our atoms in our Lewis structure. So sulfur, if we go back to the part 1 of this video lecture series, sulfur has an atomic number of sulfur belongs to group 6A, therefore it has 6 valence electrons. Oxygen, also the same group as of sulfur, would also have 6 valence electrons. However, since there are 3 oxygen atoms in our molecule, so you multiply that by 3, so we will have 18 valence electrons. So 18 plus 6, we have a total of 24 valence electrons. However, we have a -2 na overall charge ng SO3, 2 minus. So for every negative charge, we add 1 electron. Since the negative charge here is -2, so we add 2 electrons. So the total number of valence electrons will therefore be 26. Then we identify first our what do you call this? Our central atom. So obviously, sulfur is the odd one out. So si sulfur yung ating central atom. Tapos, we draw lines connecting it to oxygen atom. So diretsahin ko na. So ganyan yung mangyayari. So we have 3 oxygen atoms. We have formed 3 bonds. Each bond is equivalent to 2 electrons. So we have used a total of 2, 4, 6. We have used a total of 6 valence electrons. So we subtract that to the total number of the valence electrons. And we have 20 electrons left na pwede natin gamitin. Then we proceed to step 3, wherein we complete the octets around the atom attached to the central atom. So we complete the octets on the oxygen first. So since it already has 2 electrons, you only need to add 6 more as non-bonding electrons. 2, 4, 6, 2, 4, 6, 2, 4, 6. Okay? So that is equal, so we have used 6, 2, 4, 6. We have used 6 electrons for each of the oxygen atoms. So 6 times 3, that will be equal to 18 electrons. So we only have 2 electrons left. Okay? So saan natin gagamitin yung natirang 2 electrons? So we will use that to proceed to our step 4, wherein we complete the octet on the central atom. So we place the 2 electrons here, we place those 2 electrons here as our lone pairs. So what we are left is 0 valence electrons. So naubusan natin lahat ng ating electrons. So to further validate, we inspect the octets. So we inspect if all of the atoms has a complete octet. So oxygen has 2, 4, 6, 8. Okay, 2, 4, 6, 8. So this also has a complete octet. 2, 4, 6, 8. So this also has a complete octet. And finally, 2, 4, 6, 8 valence electrons. So the sulfur atom also has a complete octet. So this is a valid Lewis structure. Oops, before I forget, we also need to place pala the overall charge, which is -2. Okay, place it in brackets. Then the overall charge is on the upper right hand corner of the Lewis structure outside of the brackets. So another way to check this is again by checking the formal charges of each of the atoms. So let's have for sulfur. So remember the formal charges for sulfur. The formal charge of sulfur is equals to, we'll go back to our formula. We'll go back to our formula here. So formal charge is equals to the number of valence electrons minus the number of bonding electrons divided by 2 minus the number of non-bonding electrons. So we'll use that formula. So sulfur has obviously 6 valence electrons minus how many bonding electrons do we have? So 2, 4, 6. So that is 6 bonding electrons divided by 2 and minus the number of non-bonding electrons, which is 2. So we know that 6 divided by 2 is equals to 3. So 6 minus 3 minus 2, that is equal to 1. So therefore, the formal charge of sulfur is positive 1. Then let's get, since this oxygen here is the same as this oxygen here and this oxygen here, so if we get the formal charge of one of the oxygen atoms, that will also be the formal charge of all of the oxygen atoms in this Lewis structure. So let's have for oxygen. Oxygen also has 6 valence electrons because it belongs to period 6A, to group 6A. Then it has how many valence bonding electrons? It has 2, and you divide it by 2. Then you subtract the number of non-bonding electrons, which is 1, 2, 4, 6. So 6. So this will cancel each other out. So any number divided by itself is equal to 1. So 6 minus 6, that is 0. So, and 0 minus 1 is equals to -1. So the overall charge of, the formal charge of all of the oxygen atoms here is -1. So to check if our Lewis structure is correct, so we get the total sum of the formal charges of all the atoms. So for sulfur, it is +1 plus -1 for the oxygen atoms, and since we have 3 oxygen atoms, we multiply that by 3, so that is equals to 1 plus -3, and that is equal to -2. So tama, so this will be the overall charge, the net charge of the molecule. So tama yung Lewis structure natin. I mean valid rather yung Lewis structure natin. However, it says that draw the dominant Lewis structure. That means this is not the only possible Lewis structure for the sulfite and ion or your SO3 2-. So ano pa yung pwede? So let's try to make this Lewis structure as let's try to achieve a Lewis structure wherein hindi lahat ng hindi lahat ng atoms dito ay may formal charge, okay? So the only way that I can think of is to use one of the lone pairs of oxygen atom and make it add double and draw it as another bonding electron with sulfur to make an SO, a sulfur oxygen double bond. Okay? So let's check. Let's check the formal charges. So the formal charge now of sulfur is equal to 6 minus, we have 2, 4, 6, 8 bonding electrons divided by 2 minus 2 non-bonding electrons here, which is equal to, so 8 divided by 2 is equal to 4. So 6 minus 4 is equals to 2, minus 2 is equals to 0. So the formal charge of sulfur will therefore be 0. So let's have the formal charge of this oxygen here. So this oxygen will have 6 valence electrons also, and it has 4 bonding electrons. Sorry, yeah, tama. 4 bonding electrons divided by 2 minus 1, 2, 3, 4 non-bonding electrons. So that is equals to 4 divided by 2 is equals to 2. So 6 minus 2 is equals to 4. Minus 4 is equals to 0. So this oxygen will also have a formal charge of 0. Now, this oxygen, since wala namang nagbago sa kanila, this will have a formal charge of -1. Therefore, you sum all of the formal charges. The formal charge of this atom, of this molecule, rather the overall charge of this molecule will still be -2. Also, kung bibilangin mo yung number of electrons, wala naman kasi tayong dinagdag, may transform lang tayo, may nilipat lang tayong non-bonding electron ng oxygen into a bonding electron between sulfur para magkaroon siya ng double bond. If bibilangin nyo yan, you will still, the total number of valence electrons will still be 26. So nagamit rin natin lahat ng valence electrons niya. So comparing to this one here, comparing to this one here, to the previous one that we have drawn, saan yung mas valid? Obviously, based on the formal charges, this will be the most dominant Lewis structure. However, there is a problem there. This sulfur atom will now have 2, 4, 6, 8, 10 valence electrons, which now violates the octet rule. But believe me or not, this is actually the most dominant or the most acceptable or the valid Lewis structure for the sulfite and ion. We will show that later on, that there will be some exemptions to the octet rule. So let's have another example. So this one here is the thiocyanate. is the thiocyanate anion. So we go as preceded. So we have sulfur, carbon, and nitrogen. So sulfur has 6 valence electrons, carbon has 4 valence electrons, and nitrogen has 5 valence electrons. So that is equal to 15 valence electrons plus an extra valence electron because of the -1 charge of the thiocyanate ion. So that is equal to 16 valence electrons. Then we identify the central atom. So here, since this molecule is made up of 3 different elements, all of which is one atom, all of which contains one atom of the element in the molecule. So paano natin malalaman kung sino yung central atom? So in this case, in this kind of molecule, the element at the middle of the chemical formula is the central atom. So obviously, si carbon yung central atom natin. We proceed to what they call this. We proceed to step 2, wherein we identify the central atom, then draw the lines connecting the central atom with the other atoms of the molecule. So we use 2, 4 electrons here as valence electrons here as our bonding electrons. So we subtract that. So we have 12 valence electrons left. Then proceed to step 3. We complete the octets. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And since we've used 6 electrons for sulfur and 6 electrons for nitrogen to complete their octets, we have used all of those 12 electrons and we have 0 electrons left. However, carbon has not yet completed its octet. So paano yan mangyayari? So there are 2 possible ways for carbon to complete its octet. It's either the two of the lone pairs of nitrogen will be converted to bonding electrons, so that you can form a molecule which has a CN triple bond, or another way is that we can use one lone pair from nitrogen, and we can have one lone pair from sulfur to give you 2 double bonds. So you have 2 possible Lewis structures. Ang tanong dyan, sino yung mas dominant na Lewis structure? So, asa na tayo? Ayan. So, let's have for the structure what? So, let's name this as Lewis structure 1 and Lewis structure 2. So, for Lewis structure 1, I'll delete this one. I'll place this so that I can calculate. So, for Lewis structure 1, so this is for the Lewis structure 1. So for Lewis structure 1, the formal charge for sulfur is equals to 6. It has 6 valence electrons minus 2 bonding electrons divided by 2, and minus 6 valence non-bonding electrons, which is this one here. So that is equal to, the formal charge of sulfur will be -1. Now, carbon, since it has 4 valence electrons, carbon will have 4 valence electrons minus 2468 valence bonding electrons divided by 2, and we can see here that carbon has 0 valence electron, 0 non-bonding electrons, so that will be 0. So that is equals to 8 divided by 2 is equals to 4. So 4 minus 4 is equals to 0 valence electrons. Dito ko lang ilagay. Nitrogen has 5 valence electrons minus 246 bonding electrons divided by 2 minus 2 non-bonding electrons. So that is 6 divided by 2 is equals to 3. So 5 minus 3 is equals to 2 minus 2 is equals to 0. So this will have a formal charge of 0, 0, and negative 1. So the overall charge will still be negative 1. So valid tong Lewis structure na to. So how about the Lewis structure 2? So Lewis structure 2, ito yung magiging Lewis structure niya. So carbon will still have no net formal charge because no formal charge because we just transferred one of the double bonds here. Parang ganun yung nangyari. So one of the bonds here on the other side. So parang ganun yung nangyari. So understood na 0 yung formal charge ng carbon. Now for the sulfur, it has obviously 6 valence electrons minus. So it will now have it will now have a double bond, so therefore it will have 4 valence electrons divided not valence electrons, sorry, bonding electrons divided by 2 minus 1, 2, 3, 4 non-bonding electrons. So 4 divided by 2 is equals to 2, and 6 minus 2 is equals to 4 minus 4. So the formal charge of sulfur is 0. Nitrogen, we'll calculate the formal charge of nitrogen, which has 5 valence electrons, minus how many bonding electrons it has, also 4, divided by 2, and it will also have 1, 2, 3, 4 non-bonding electrons. So is equals to 5. So 4 divided by 2, that is 2. So 5 minus 2 is equals to 3 minus 4, that is equal to negative 1. So this is negative 1. So the overall charge here is negative 1. So basically, between formal charge wise, the formal charge was actually just transferred from the sulfur atom to the nitrogen atom. If we look at Lewis structure 1 and Lewis structure 2. So ngayon, the debate is how do we know which is the more dominant Lewis structure? So we go back to this rule here. This rule here says that a Lewis structure in which any negative charge resides on the more electronegative atoms is generally more dominant than the one has negative charges on the less electronegative atom. So in order to determine, or rather in order to determine which of the following structures is more dominant, we need to know which of the following atoms between sulfur and nitrogen is more electronegative. So we go back now to our trusty periodic table. So if you see, I don't know if you can see. So if you see here, in nitrogen, so this is our electronegativity here. In nitrogen, nitrogen has an electronegativity of 3.0, while sulfur has an electronegativity of 2.5. Since nitrogen has a higher electronegativity value than sulfur, therefore, nitrogen is more electronegative than sulfur. So, mas mabuti na yung negative na formal charge will reside to nitrogen than in sulfur. Therefore, this Lewis structure here, this Lewis structure here is our dominant Lewis structure. So, erase this one. We'll erase everything. So rather, the correct or the dominant, or rather, the correct. The more appropriate answer is the correct Lewis structure for the thiocyanate anion is this one. Is this structure. Okay? So, let's try another exercise wherein we draw the Lewis structure first, then we get the formal charges for each atom in the following molecules. So, let's have... Hala, I forgot to show. So, eto pala. I forgot to show it pala. Sorry. I got carried away. So, eto, again, yung Lewis structure yung valid Lewis structure ng ating, eto na yung dominant Lewis structure ng thiocyanate ion, since the negative charge will reside on, what they call this? Sorry, the negative formal charge will reside on the more electronegative nitrogen atom. Okay, so, again, let's try an exercise wherein we determine the formal, we draw the Lewis structure first, then we determine the formal charge for each atom. So let's have CO, or your carbon monoxide. So carbon has 4 valence electrons, and oxygen has 6 valence electrons. So we have a total of 10 valence electrons that we're going to use. So carbon and oxygen, obviously, hindi So, paano natin malalaman kung sino yung, anong tawag dyan? Kung alin yung valid na Lewis structure? Paano natin malalaman kung sino yung central atom? So, ideally, actually, there is no central atom here. Okay? So, we surround them with octets. So we try to complete the octets by utilizing all of the 10 electrons here. So we already used 2 for the bonds. So minus 2, we only have 8 electrons left. Okay? So what we can do is we can also distribute these 8 electrons left equally on the 2 atoms. But if you do that, if you distribute them as lone pairs or as non-bonding electrons, you will have an incomplete octet. Okay? So what we can do is para mag-complete octet sila is we form a CO triple bond, right? So we have 2, 4, 6 valence electrons na nagamit. Then we have 4 valence electrons left, so we distribute those 2 evenly. Okay? So this will be the correct Lewis structure. Now, we determine the formal charge of each. So carbon has a formal charge, carbon has 4 valence electrons minus from the bonding electrons from the triple bond, so that is 6 valence electrons divided by 2 minus 1, 2 non-bonding electrons. So that is 3. So 6 divided by 2 is equals to 3. So 4 So 4 minus 3 is equals to 1 minus 2 is equals to negative 1. So carbon here will have a formal charge of negative 1. Oxygen has 6 valence electrons, and it will have 6 bonding electrons because of the triple bond divided by 2 minus 2 non-bonding electrons. So that is equals to 6 minus 3 is equals to 3 minus 2 is equals to positive 1. So oxygen will have a formal charge of positive 1. So that will be the formal charge of each of the atoms for the molecule na carbon monoxide. And if you will see, the carbon monoxide is a neutral molecule. It has no net charge because the formal charges of the two atoms will cancel each other out. Now the question here is, if you look at the periodic table, oxygen, which has an electronegativity of 3.5, is more electronegative than carbon, which has an electronegativity of 2.5. However, ano tawag dyan? Carbon has the negative charge while oxygen has the positive charge, which is contradicting to the rules of determining which is the dominant structure. Now the explanation for this is that there's no other choice. That in order for you to have a correct or a valid Lewis structure, eto lang talaga, this is the only way to go. Wala ka na talagang ibang magagawa dyan. Okay? So let's have last example. So let's have hypochlorite, an ion. So oxygen will have 6 valence electrons, while chlorine, has, going back to the part 1 of the video, has 7 valence electrons. So that is equal to 6 plus 7, 13 valence electrons, plus we add an extra electron because of the negative 1 na charge. So that is equals to 14 valence electrons. So then we use up all, what do you call this? We use all of the oxygen, I forgot the term. We draw the Lewis structure. We proceed to number 2. So since wala tayong central atom, dahil dalawa lang naman sila, so diretso na natin na we draw a bond there. Okay? So this uses up 2 electrons. This bond uses up 2 electrons. So we subtract that from our total tally of the valence electrons, and we have 12 electrons left to spare. So what we can do is distribute the 12 electrons evenly throughout between 2 atoms as lone pairs, and we have now our Lewis structure. So let's check if our Lewis structure is valid. So chlorine, so the formal charges of each of the atoms, we have to calculate it first. So chlorine has, so for the formal charge of chlorine has 7 valence electrons. We minus that with 2 bonding electrons divided by 2, and we subtract the number of non-bonding electrons, which is 1, 2, 3, 4, 5, 6 non-bonding electrons. So 2 divided by 2 is equals to 1. So 7 minus 1 is equals to 6 minus 6 is equals to 0. So chlorine here has no formal charge. Oxygen will have 6 valence electrons minus 2 bonding electrons from the single bond divided by 2 minus also the same 6 bonding electrons, and it will have a formal charge of negative 1. So this will be the only and dominant Lewis structure. This will be a valid Lewis structure for oxygen, for hypochlorite rather. Now, which kind of makes sense? Because if you look at, again, our periodic table, oxygen is more electronegative than chlorine. Oxygen has an electronegativity of 3.5, while chlorine has an electronegativity of 3.0. Therefore, it makes sense that we put the negative charge on the oxygen, the negative formal charge on the oxygen atom. Okay, now to answer your question, to answer the inquiry, to answer the what do you call this? The aberration, I guess, on the valid Lewis structure of SO3 2-. So here's the question. So we have seen that in the sulfite anion that we have shown earlier, that that the sulfur atom has gone beyond 8 valence electrons. Okay, so the question is the octet rule absolute in chemical bonding? No, because there will be some elements, particularly those on the elements of period 3 downwards in the periodic table, that can go beyond the octet, or what we call as the expanded octet, and some of them will even have an incomplete octet, which is the compounds of boron. We will explain that as we further progress in this topic of the basic concepts of structure and bonding. This is just part 2. We will discuss that on the later parts of this lecture series. Now, can carbon violate the octet rule? Well, in the context of organic chemistry, in the lessons that we will tackle all throughout this course, carbon cannot go beyond 8 valence electrons. However, recent researchers have shown that it can go beyond 8 electrons, and such a compound wherein carbon can form more than 4 bonds have already synthesized. So this is the compound that I am talking about, wherein carbon is bonded to 6 other atoms, and it was even isolated in its solid form. So if you see it here, we know that carbon can form only 4 bonds, right? Now in this case, it can now form 6 bonds. Now this compound only exists is only stable in magic acid solution, or in this is the magic acid solution here. It only is stable in this solution, and it's only stable at -78°C. Now, if you try to recrystallize it or convert it into solid form, you have to maintain that 78°C na temperature. Otherwise, the solid will collapse, and this hexavalent carbon here that I've shown you here will no longer, this hexavalent carbon that I've shown you here will no longer exist. Bakit naglalag yung aking pen? Sorry. Will no longer exist. Now, there have been computational methods that have been done that carbon can also a compound that has carbons bonded to 7 other atoms can also be can possibly exist. Okay, but however, it has yet to be synthesized, and just like the hexavalent carbon, this kind of compound will only exist at even lower temperatures. So hindi pa, again disclaimer, hindi pa ito nagagawa, hindi pa ito nasisynthesize, unlike this one that I've shown here. Ito, hindi pa nasisynthesize. In theory pa lang to, na pwede siyang mag-exist, pero hindi pa siya nasisynthesize. But if ever it will be synthesized, it will only exist at even lower temperatures than the 6 bonded carbon. Okay, so this is the end of my presentation. Don't forget, thank you for watching and listening to this video. Don't forget to hit the to hit the like button and subscribe. Okay, so that's it. This is again your resident round bottom flask, and see you for the next series of lecture videos, not only on the basic concepts of structure and bonding in the context of organic chemistry, but also to the other videos to come. Okay, that's it. See you guys.